Good morning, dear students. Today we are going to discuss the first use of the potentiometer device, that is to compare the EMF of two given cells in a circuit. In order to compare the EMF of two given cells, the required electrical circuit is shown in this figure. In the primary circuit, that is here, a storage cell that is represented by capital letter C and a key K1 and a variable resistance, that is rheostat RH, are joined in series between the points A and B. The two cells whose EMF are to be compared are joined in secondary circuit such that their positive terminals are connected to point A and negative terminals are connected to a two-way key. A galvanometer G and a jockey J are joined as shown in this figure. So let's see how we can compare the EMF of two given cells by using this circuit. First of all, the circuit should be completed as shown in this figure. Now you have to put the key K1 so that we will allow current into the main circuit. So when we are putting the plug into K1 means the switch is on. When we are switching on the circuit, we will allow the current into the main circuit. Now by switching on one-way key, this K2, we allow the current in this circuit, that is secondary circuit, with the help of the cell E1. Now this jockey is slided at the end A and the direction of deflection for this galvanometer is noted down. So when the jockey is being rubbed over this potentiometer wire, this galvanometer will show a deflection. That means current is being flowing through the circuit. So galvanometer will show a deflection, and that deflection direction, galvanometer pointer is like this. It can show a deflection to both left side and to right side. Zero deflection means center point. So it can show a deflection in this direction, and also it can show a deflection to this direction also. So it should be noted. Again, the jockey is being placed at the point B and the direction of the deflection should be noted down. Both the deflections must be opposite. That means both the pens are at the opposite direction, both the points are at the opposite direction. So the deflection should be also opposite in direction. This indicates that the circuit is perfectly correct. After this, by putting the jockey at appropriate position, we try to get the null point. Null point means when we move the jockey over this line at a particular point, at a particular length, we will get a zero deflection. That means the galvanometer point will lie at a zero division. That means it is the balancing length. We have studied that one last days also. So after finding this null point, that distance from A to the point J should be marked. Let the distance of the null point from A is L1. Let's take it as L1. So that's the first balancing length. We were saying about the battery E1. So the first balancing length can be taken as L1. Now by removing the plug from one-way key, we disconnect the cell E1 and then we switch on the way 2. That means this one. This one is closed and this one is open, and now this one is closed. So E2 is being switched on and current will be allowed to flow through E2 because of E2. So we are putting the cell E2 into the secondary circuit, and with the help of the jockey, the distance of balancing point, that means the null deflection point, from point A is determined. Same like the previous one. After connecting with the E2 cell, we are going to find out the balancing length. That means because of E2, what is the next balancing length? So we have identified the balancing length due to E1. So now it should be with E2. So balancing length can be named as L2. So at a particular point, at a particular distance, you will get a galvanometer zero division, null point, that can be taken as the balancing length due to the cell E2 and can be named as L2. So because of E1 it was L1, and because of E2 the balancing length is taken as L2. By varying the current through the circuit with the help of this rheostat, we are varying the current through the circuit so that we will get different sets of balancing length. Now we have done the connections and we did the procedures. So the cells whose EMFs are to be compared are joined in the secondary circuits, and null points also we have obtained one by one. Let the EMF of the first cell be E1 and the corresponding balancing length of E1, let it be L1. We have already seen that. For E1 the balancing length is L1. By rubbing the jockey over this wire, we are getting the null point deflection at L1 distance. And same as the above previous case, for E2 it should be, the balancing length should be L2. So according to the principle of potentiometer, yesterday we have seen the principle of potentiometer. What was the principle of potentiometer? EMF E should be proportional to the balancing length, otherwise E should be equal to potential gradient K into balancing length L. So here two balancing lengths are there. So you can write like this: E1 will be equal to, potential gradient is always a constant value, K into L1, that is equation number 1, and EMF of second cell will be equal to K into L2. E equals KL is the principle of potentiometer. We are using the same equation here also to compare the EMF of two cells. So E1 will be equal to K into L1 and E2 will be equal to K into L2. So we have got two equations for E1 as well as for E2. And look at the question: to compare the EMF of two cells. For doing a comparison, we should find out the ratio. So we should dividing equation 1 and 2, we will get the comparison. So E1 divided by E2 will give you the correct answer. E1 divided by E2 will be equal to KL1 divided by KL2. What can be the answer? E1 by E2 will be equal to, K and K can be cancelled out, and final answer will be L1 divided by L2. This is the desired equation. Thus, by obtaining the balancing length L1 and L2 experimentally, we will be able to compare the cells EMF E1 as well as E2. So if the question is being asked, what is the comparison, how to compare between two cell EMF value E1 and E2, simply calculate the balancing length provided by each of the cells L1 as well as L2. Then after finding out L1 divided by L2, you will get the comparison. That means E1 is to E2. That is the final answer. Thank you, students.